So as we continue examining equations, now we're going to talk about equations of linear functions. And in essence, a linear function is a function which has the highest degree variable is 1, x to the first power. That's what we're talking about when we say linear functions. There are three main forms of linear functions that you'll encounter. You have point-slope form, standard form, and the slope-intercept form. The slope-intercept form is the most common for students because that's what you first start using in approximately 7th grade, 8th grade. And of course, point-slope form and then standard form, those are often ignored or overlooked because, something you're familiar with is often the easiest, but each one of them have a benefit. And so we'll look at those, and we want to write linear equations in standard form, being able to identify what the values of A, B, and C are. Identify equations in slope-intercept form using the coordinates of 2 points. So we want to be able to create the slope, determine the slope based on points, and then using it in the equation. Create linear equations in point-slope form using 2 points and a line, or a slope and a point. We want to be able to create the slope if we don't know the slope, and then fill in the formula. So with that, looking here, linear equations in standard form. The most unfamiliar for students. So here, this is my slope-intercept form, y equals 2/5 x plus 14, and they want you to write it into standard form, and they want you to identify what my A, B, and C values are. Standard form is ax plus by equals c, where a has to be a positive number, and a, b, and c are integers with the greatest common factor of 1. So when they say integers, what you can't have is 0.5x plus 3y equals 10. Why not? They're saying that it has to be an integer, so 0.5 isn't an integer. What I need to do to make that an integer, I can multiply everything by 2 times 2, and if I do that, then this just becomes 1x plus 6y equals 20. Now it is in standard form where we can identify an A, a B, and a C. And they say that the greatest common factor has to be 1. The greatest common factor of these items is 1. An example of when it would not be the greatest common factor of 1, if, for example, I had 3x plus 9y equals 12. Those all are still divisible by 3, so that would be a factor that I can factor out from all of those, and that is the same as x plus 3y is equal to 4. So that's what they mean by those two criteria. Has to be an integer, cannot be a decimal or a fraction, and then of course we want to make sure that they do not have a common factor which greater than 1, and these all had a common factor of 3 that we could factor out. So there you go. That's what they're talking about in that definition and criteria. So here, first of all, getting it into the form of this, we have our constant is going to be to one side of the equation, and then the x and the y will be on the other side of the equation. So here, they have y over here. We need to move the x over to the other side, and in order to do that, we would subtract negative 2/5 x from both sides. That's why it disappeared here. And then we have 2/5 x. Let's see here. I'm sorry. Since we have a fraction of fifths, they're saying if we multiply by 5, that will eliminate the fraction. So we multiply everything times 5, and then it would have equaled 10/5, negative 10/5 x plus 5y is equal to 70. And this 10/5 is what's simplified to 2x. So 2x, they multiply by negative 5 because that's negative times a negative became a positive, so that's my bad. So that's how we get a positive 2x minus 5y equals negative 70. And then this would be my A, my B, and my C. Okay, so that is just being able to identify what those factors are. Now, graphing later on, we find out standard form has its benefits. So being able to do that. So writing here in standard form, we have 2y equals 10x minus 16. I'm going to go ahead and subtract 10x from both sides. I have negative 10x plus 2y is equal to negative 16. Remember your a value that in front of the x has to be positive, and they also have a common factor. They're all divisible by 2. So I'm going to divide everything by negative 2, and I end up with 5x, minus y equals 8. So that's the standard form of the equation, and a is 5, b is negative 1 because there's a negative 1 in front of the y, and c is 8. So there you go, being able to identify those, and we'll graph these later on. You may recall you can get the intercepts really easy. Linear equations in slope-intercept form. Slope-intercept form is y equals mx plus b, the most common form. M is your slope, b is your y-intercept, and we have covered this, just a few days ago, and how to graph that. When you're graphing, you start at your y-intercept, and then you move up and over or down and back based on your slope. So this line intersects at 1. So I know that my y-intercept is 1. Y equals x. I have to figure out what is my slope. And here they're saying we went up 2, right 3. So positive 2, positive 3. You could have said, so there my slope is 2 over 3. If you look, we could have, if you went down instead, if you went down, that would be minus 2 minus 3, which is equal to negative 2 over negative 3, because a negative divided by a negative is actually a positive. So either way, we have a slope of 2/3. So that's what we're being able to determine what my y-intercept is, determine what my slope is, and insert that into the equation. And as a reminder, here's the information: slope-intercept form, slope, the y-intercept, and then slope is the rise over run, which is on your state form, your reference sheet, as y2 minus y1 over x2 minus x1, which is the change in y over the change in x. So here, doing your inverse operations, we're going to write this standard form into slope-intercept form, identify the slope and the y-intercept. So they subtracted 12x from both sides because they want to start to isolate the variable. Now, in order to get y by itself, we're going to divide by 4. And then y is going to be equal to 3x minus 6. Your slope is 3 over 1, and then your y-intercept is negative 6. Okay, so being able to do that, this is a literal equation where I've identified a variable I'm trying to solve for, and then I use my inverse operations to isolate it. That's what we did. We identified y and we isolated it. So I have 4x is equal to negative 2y plus 22. I'm just going to start here. I'm going to subtract 22 from both sides, and I have 4x minus 22 is equal to negative 2y. Divide by the coefficient, negative 2, negative 2, negative 2, and y is going to be equal to negative 2x plus 11. Okay, so there we go. We were able to do our inverse operations to isolate the variable we chose. Now, interpreting those equations, remembering that slope-intercept form has a constant, which is my y-intercept. You know, that's where we intercept the y-axis. It's sort of like an initial cost, an initial fee, a starting point, and then you have your slope with something changing over time. So that slope is going to be your what is affected by change. So here in this equation, 3,246x minus 2y is equal to negative 152,722. This can be used to estimate shoe sales in Europe from 2010 to 2015. X is the number of years after 2010, and Y is the revenue in millions of dollars. So write the equation in slope-intercept form. Okay? So they did some inverse operations here. They want to get Y by itself, so they subtracted negative 3,246x from both sides. Then they still need to continue to isolate Y, so they divided everything by negative 2, and my slope-intercept form is Y equals 1,623x plus 76,361. What does that mean? This is my change, right? This is what changes over time. So it looks like my sales of shoes increase 1,623 each year because X is the number of years. So depending on the number of years, and then 76,361 is like my starting point, my y-intercept. That's where at 0 years I would have estimated that to be sold. So represents the sales increased this million each year, represents that in year 0, or in year 0 is 2010, because that's the starting point. Sales were 76,361. So years since, we can calculate that. Using an equation, using a linear equation in slope-intercept form, smartphones. In 2013, there were 1.31 billion smartphone users worldwide. By 2017, there were 2.38 billion smartphone users. Write and use an equation to estimate the number of users in 2025. Okay, so what is my variable? X is going to be my years, and Y would be the number of smartphone users. And if I think about a starting point, in order to create a slope, you can do it with 2 points. And that's what I've sort of shown you here is in 2013, we had 1.31. In 2017, we had 2.38. So that's what they did here. They took those values and they came up with the slope, which was 0.27. 0.27 is my slope. So I have, y equals 0.27x plus, what was my starting point? So 0.27 billion per year is what they come up with. 2013, 1.31, we just came up with, and then the y-intercept represents the number of smartphones used when X is 0, or in 20, where we started. And then write that equation, I think 0.27x plus 1.31 is going to be the values. And then since 2025 is what we're going to calculate, that is 12 years after 2013, we substitute 12 in for X, and we come up with 4.55 billion smartphone users. As a side note, right now when we dial a phone number, we have to use 10 digits. The amount of smartphones that are being produced rapidly, that we are soon going to have to dial more than 10 numbers to reach someone, because those 10 numbers we're using those up. the possible combinations. We've used those up, and we're going to start having to dial more numbers. But anyway, just gee whiz. So linear equations in point-slope form. Let's see, the equation of a linear function can be written in point-slope form, and this is it. Y minus y1 equals m times x minus x1. This is my ordered pair, right? X and y point value, and this is my slope. The rest of this remains in this is part of the equation. That is part of the equation. That never changes, okay? That remains the same. The only thing that we're going to go back and actually change is going to be the y value, the x value, and then the slope. All right, so point slope. Here, write an equation in the line that passes through. Here's my x, my y, and it has a slope of 11. So we just substitute those values in. So here's my y1 is -5, my x1 is a +3, and then my slope was 11. So that gives me negative times a negative becomes a positive. So here is my point slope form. And then it says write that equation. Now for our check, it says write the equation of a line that passes through here and has a slope of 4.5. Again, y minus equals the slope times x minus, and we fill in the blanks. My slope, they said, is 4.5. My y is going to be -5, and my x is going to be 13. So I have y plus 5 is equal to 4.5 times x minus 13, and that is point slope form. Okay. Now, if you needed to go from point slope to slope intercept form, I think I'm going to show it to you here in this next example. But let's see here. Point slope form given 2 points. Given 2 points, we have to calculate the slope first. So in this case, they said this is x1, y1, x2, y2, and they used those in my slope formula to find out that the slope was 12 over 6 or 2. So I know that slope is 2, and then now in order to write the equation in point slope form, I've done it right here. Many students will say, well, which point do I use? It doesn't matter, it's the same equation of a line. So I used this example, and I used slope is 2. Okay, slope is 2. In the first example, I used point 1, 1. So y was 1, x is 1. And now to show you that it is the same thing, I went ahead and distributed. So this is point slope form, but if I distribute and I put it into slope intercept form, you know, I distributed my 2, I added 1 to both sides, and this is slope intercept form of the equation. Well, if you'll notice, when I use 13 and 7 as my other point, 7, 13, when I replaced 7 and 13 and I distributed, I added 13 to both sides, the two equations are the exact same. So it doesn't matter which points you use, as long as you are doing your proper operations using the proper formula, it is the same equation of the line. We just recognize it. So there's 2 ways to write it in point slope form, because you can use 2 different points, or there's 1 slope intercept form. So, and there we go. So that was them giving you the answer like I just did. But I'll just say in this one, same thing applies here, that I have 2 points. And I know that if I calculate my slope, and we'll just say this is y2, x2, y1, x1, slope is going to be 13 minus 1 over -2 minus -1, which is going to be 12 over -1, I think. Okay, so 12 over -1 is going to be -12. My slope is going to equal -12. So I can immediately remove any problems here that have a slope of a +12. Darn it, they all have -12 as my slopes right here. See that? Okay, so that didn't help me. But let's see, this point right here, the formula, what does my formula call for? Y minus y1 is equal to my slope times x minus x1. So I will say right here, that is the wrong format for my equation. That should be y. So I can remove that one, I can remove that one, I can remove this one, and I can remove this one, because they are not the right format for point slope. And then if I look for my y value, this should be y minus 1, using this point right here, is equal to -12 times x minus a -1, which is going to be a positive. So I have x minus 1. This has x plus 1. That's not possible. Okay, so we are whittling away answers that are not the same. Looks like this one is possible. And then if we use the next one, this point right here, that should be y minus 13 is equal to -12 times x plus 2, which is, I think, this one right here, and then this one would be removed. So those are the two possible choices. Okay, two possible choices for point slope form. And then write and interpret a linear equation in point slope form. Well, thinking about it, using my ordered pairs, the Tower of Pisa began tilting during the construction in 1178 and continued to move until the restoration effort reduced the lean and stabilized the structure. The Tower of Pisa leaned 5.4 meters in 1993 compared to the lean of just 1.4 meters in 1350. All right, so roughly 643 years, it moved 4 meters. But write an equation in point slope form that represents the lean y in meters for the Tower of Pisa after its construction in 1178. So the tower was leaning again in 1350, which was how many years away? And then 5.4 meters in 1993, which was how many years away? So that's how they came up with my x and y. I have 1.4 at 172 years, and I have 5.4 at 815 years. So those are my x and y coordinates. They calculated the slope, and it looks like the rate of change was 0.006 meters per year. So that is my slope. And then you can pick whichever equation, whichever point you want to create the equation of a line. And they used this point right here. So they put in y minus the 1.4 is equal to my slope times x minus the 172. So there you go. That's what they're talking about here as we adjust and we use the point slope form. So with that, what we will do is we will tackle some of the problems now and see how it goes. Each one of these has its own benefits. It's just a matter of moving the formula around that best serves us and answers the question they're looking for.